Hi, my name is Sai Harshvardhan. We are from Team 1 and our teammates are Divya Bandari and Sai Harshvardhan, me and Rohita Goparazu. Today we are going to discuss about the uh, Lab 2 Python. Coming to the Lab 2, it's deep learning. The first question is about the linear regression. We have to build a sequential model using a keras to implement the linear regression with any data set of our choice, and and we need to plot the graph in the tensor board, and we need to change a few hyperparameters like learning rate, batch size, optimizer, and activation function. And the learning rate is a configurable hyperparameter, and it ranges from 0.0 to 1, and it will be always in the points, I mean fraction. And coming to the batch size is the number of samples processed before the model is updated, and the batch size must be more than 1 or equal to 1, and it should not it means the batch size never be a 0. Coming to the optimizer are algorithms or methods used to change the attributes of your neural network, such as learning rate, weights, and other factors, which reduces the losses. And coming to the activation functions is a mathematical gate between the input field in the current neuron, and its output outgoing to the next layer. All these four hyperparameters we are going to change and see the fluctuations in the loss. Coming to that, here I'm going to run the data in the linear regression. In starting, I have imported all the things which I need to run that in the imports, and then I have imported the TensorFlow to show the graph. And in this, as it is a sequential model, I have written the model in the sequential model, and then I have without changing any linear any other parameters, I have started writing the code. And at that time, the loss and the accuracy were plotted in the graph, and we got around 0.99%, 99.69% as a validation loss, and training loss is at 93.49. Coming to the graphs, here I have plotted the graph for all the epochs, and then I have started changing the hyperparameters like learning rate here, and I have changed it to 0.008, and I have plotted the same graph for the loss and accuracy. The values are changed to more than 100. It's 139 loss, train loss, and variable value loss is around 175 validation loss, and the losses are plotted in the graphs in the similar way I have done for the batch size and optimizer and activation functions. The changes can be seen here. It is hugely increased to 500, and the graphs is like this. And when I have the other one, when I change the activation function from ReLU to tan-h, it will be around 573 as a training loss, and validation loss is 639, and the graphs for each epoch were plotted using TensorBoard. Coming to the next program, it's a logistic regression. Here we are going to get the data set like a heart disease, and this data set is from Kaggle, and we are going to normalize the data before feeding it to the model, and then we are going to show the loss in the TensorBoard, and then we are going to change the 3 hyperparameters like similarly which we have done before. And the difference between the logistical regression and the linear regression, we can say it as basically both are the basic form of the regressions. But in logistical regression, it is used when a dependent variable is binary. But when coming to the linear regression, it is used when the dependent variable is continuous and continuous in nature of a regression line and nature of regression line will be in linear. This might be a change between the this means the one of the difference between the linear regression and the logistical regression, and we are going to do the same activities which we have done it before for the linear regression, and those things I can show in the second program. Here I have imported the heart CSV which it was given in the code, and then I have plotted the graph for validation loss and the training loss as I have done in the here as I have done in the previous one, and have normalized it before creating the model. And here I'm going to normalize the values with a range of 0 to 1, and then I started working on a different epochs, and the accuracy is around 0.77 and the loss is 0.54, and the tensor board graph is shown in the for the different epochs in the results. And then I have started changing the learning rate, and the same thing I have plotted, and same validation loss and the training loss were plotted, accuracy were plotted. It's around 0.745 and 0.79 changed respectively, and those two graphs are plotted for each and every epoch in the tensor board. And then I have changed the activation function from ReLU to some other, tan h, and these are the epoch results for these are the results for each epoch, and the validation accuracy is changed to 0.77 and 0.52 as a loss, and the graphs also can be seen respectively. And later I have changed the in this I have changed the batch size, which is one of the hyperparameter, and then I have and I found these following results, and graphs are plotted as below. Coming to the third program, here we are going to implement the image classification using CNN model on any one of the following dataset. Since this is a CNN model, our project also is worked on a CNN model, convolution neural networks. I have selected 10 monkey species, and I have took the dataset from the Kaggle and I stored into my Google Drive, and then I took the path from that and I have given it to the path variables, and then these and the labels were taken in from to the monkey labels, and then I used this sequential model, and I used ReLU function to as an activation layer with a 512 neurons. Since it's a convolution, we have used a con2D, and then I have started plotting the graphs and plotting the loss as below, training and accuracy and loss as below. Here you can see the variable loss and variable accuracy parameters, and these both are the graphs for the validation validation accuracy and loss. Coming to the fourth program, it was a implementing of a text classification using CNN model on following movie review dataset. And here the same thing we are going to do using LSTM model. These both are the two different models where we are going to do now on the same dataset, and we are going to check what is the difference. That is the sixth question. Now I'm going to see we are going to see the fourth and fifth. The fourth one, is a CNN model, which is works on the movie review, sentiment analysis of the movie review. I have imported all the packages, and I have took the train data and test data, and I placed it in the Google Drive and gave the path to the data, and I have used those two variables as a in the code, and I created a model called a sequential, and then I have started using conv1D for the as a layer with 128 neurons and activation as a ReLU, and then I have started running around 15 epochs. For one epoch, since it is taking too much time, I have ran one epoch at the first time, and then I have ran two epochs, and then I have plotted the accuracy of loss. These are the two accuracy and loss of the loss which is plotted. This is the accuracy loss for the fourth one. Coming to the fifth one, I'm going to use the LTSM for the same data set, and I have taken the training data set and test data set and stored in the Google Drive, and similarly which I have done for the fourth program. And I started creating a model with a sequential, and I have used the LTSM layer here. You can see with a dropout of 0.2, this is 20%, and use the output layer, output activation as a softmax, and then I have started plotting the graph. It's around as it's like a accuracy loss, and graph will be seen like this, and the valuable accuracy is 0.61 here. And when coming to the valuable validation accuracy for the program for convolution is around 0.51. These are the things, these are the differences we have when compared to the when we come for the validation loss for both LTSM and CNN. Before that, and one more difference between the LTSM is used to process and make the prediction on the given sequence of data, but CNN, in contrast, CNN is designed to exploit the spatial correlation in the data and works well on the images and the speeches. This is one of the difference which works with both LTSM and the LSTM and CNN. And coming to the sixth program, this is the comparison which I have done on CNN and LSTM from the above programs. And coming to the seventh one, it's seventh one, apply the auto encoders on MNIST dataset and show encoding and decoding on particular image. Coming to that, here, what is meant by autoencoder? It's a type of ANN, artificial neural network, used to learn efficient data encoding and in unsupervised data. And coming to that, here I have data, and these are the encoded, and I have created a dense layer with encoded dimensions and decoded with the neurons of 784, and I have created a model called autoencoder, where I have given input image and a decoded function, and this encoder gives this input image and encoded values to this particular encoder variable, and then we are going to get the encoded input with input encoding dimensions, and in the decoder layer we are going to using the decoder layer we are going to retrieve the lost layer of the autoencoder model, and then we are going to create a decoder model. And and I have plotted this graph into using matplotlib in the results, and you can see the results using matplotlib. This is the noise which was created. We have removed those noise, and the validation accuracy is nearly 0.5, and we have run 10 epochs on this. Thank you.